In this video, I will present again the circular functions, and at the same time, this is going to be somewhat like a summary of what we have spoken about, the wrapping function, the arc lengths, and the circular functions. So we spoke about the wrapping function. It is a function from the set of real numbers to a set of points in your unit circle. For every real number t, there is a corresponding point for that t. And that point is the endpoint of an arc of a unit circle whose length is t. And so our circular functions are sine, cosine, tangent, cosecant, secant, and cotangent. So the values of these functions have to do with the point that corresponds to an arc whose length is t. Sine of t is equal to the y-coordinate of that point. Cosine of t is equal to the x-coordinate. Tangent of t is y over x, so on and so forth. As a corollary to the wrapping function, I also introduced the corresponding points for your special angles. It's going to be a challenge to write down and really to discover what are the points that corresponds for any real number t. But for special angles, we know what those points are. And we have shown that when the length of your arc is t, when the value of t is pi over 4, the corresponding point is this one. And you can find all information about special angles and the corresponding points in this picture. This picture tells the special angles and corresponding points. So when you combine these two together, the circular functions and the corresponding points, if you have a point which is an endpoint of an arc whose length is t, and this arc is an arc of a unit circle, the x-coordinate of that point is cosine of t, and the y-coordinate is sine of t. You know what? Those things put together will appear in a table such as this. So this is a photo of a page from my book. This is a summary. So in the first row, you have the value of t's, and the second row would be the corresponding points for that t. And these functions are the circular functions. These are the circular functions, and the numbers here are the values of your circular functions as a function of t. So this is a big chunk of knowledge. When I first saw this, I was a first-year college. I didn't have trigonometry in high school. Which is why this is quite overwhelming for me. But you know what? You don't have to cram into your mind all that information. What you can do is you can just pay attention to this simpler table. On the first row, you have the special angles. And on the second row, you have the corresponding point for these special angles. So how do you find the circular functions? Well, you just remember that the x-coordinate is cosine of t. So for example, what is cosine of pi over 3? So what you do is you look at the radian measure pi over 3 and the corresponding point and look for the x-coordinate of that point. And the x-coordinate is 1/2. So cosine of pi over 3 is 1/2. Let's say, for example, tangent. Tangent of pi over 4. So you know tangent to be y over x. So you go to this cell, to this box, pi over 4, and the corresponding point for that is this one. So when you get y over x, it's just equal to 1. How about when, let's say, for example, secant of pi over 3. you know secant to be the reciprocal of your cosine function. So this is like finding what is cosine of pi over 3. Okay, so what is cosine of pi over 3? Well, that's the x-coordinate of the point that corresponds to pi over 3. So it's going to be 1 over 1/2, and that is equal to 2. So you see, you don't have to force your mind to absorb what was written in the larger table that I showed to you earlier. This is what you can focus on. This is a much simpler collection of information. So this is quite a journey for you. You began studying this way back in grade 9. So this is a screenshot of my supposedly to be published book in junior high school mathematics, but it's been put on hold because of the pandemic. So you began talking about trigonometry here. You didn't call it circular functions. You call it trigonometric functions or trigonometric ratios, and they have to do with the right triangle. So many students cling to their understanding of trigonometric functions as the ratio of the sides of a right triangle, and that's going to be a big handicap for you. So usually students who what they remember of trigonometry is SOHCAHTOA. But this is helpful only when you are working on an acute angle, okay? An angle that you can find in a right triangle. But what about when the angle is not an acute angle? Let's say, for example, 0 radians or 0 degrees. Is it even possible to form a right triangle whose one angle is 0 degrees? But when we go to circular functions, yes, we can. When the degree measure is 0, that is just the same as the radian measure is 0. Cosine of 0 is the, look at that, that's the x-coordinate of the corresponding point for 0 radians. So cosine of 0 is 1. But that is not possible to see right away when you are working, when you are stuck to SOHCAHTOA. So as a pre-cal student, and I am assuming you are aiming to pursue a degree in engineering or in degree programs with much mathematical content, I advise you not to cling to SOHCAHTOA because it's going to be a big handicap for you.